Guys, this is 805 part 2. We're going to go through some sample problems on collisions and talk about whether things are elastic or inelastic. To start off with, there's the bell. An empty sled is sliding on frictionless ice when Susan drops vertically from above a tree above onto the sled. When she lands, does the sled speed up, slow down, or keep to the same speed? So first of all, I want to know where's Susan's mom that she's jumping out of trees and onto sleds. But since we're in physics, we're not going to concern ourselves with that. Take a second, pause the video, see if you and give yourself some time to see what you think the answer is. Okay, did you say slow down? If you did, you got it right. So if we start off and let's say the sled, my sled is that's a runner. You guys know I can't draw. Is 2 kilograms and it's going 2 meters per second. That's going to give you a momentum of 4. Let's say that let's just make it easy and say Susan weighs 10 kilograms. That's not going to be very accurate, but we're going to have a final momentum of 10 plus 2 equals my final velocity. And we can clearly see that that final velocity is going to be less than the initial. Now, what I did here was I used rule of ones where I plugged some values in to get a mathematical proof. But we should be able to answer this at some point then conceptually and understand that in a system that has no external forces, momentum is conserved. And if you increase the weight, so if you have, let's see, we've got mv1 equals mv2. Understanding our proportionalities, that if we increase the weight on this side, that the velocity is going to have to go down to keep the value here. Understanding that when things are on opposite sides of the, on the same side of the equation, they're inversely proportional. All right, so problem 4. Just going to slide my camera down. So one of those AP problems. We have object X travels across a horizontal surface and collides with object Y. The velocity as a function of time for object X and object Y before, during, and after the collision is shown in the graph. Both objects have a mass of 2 kilograms. Which of the following correctly describes the momentum P of the system and the kinetic energy K of the system? Okay. Read this. If you want to copy it down, that's fine. Pause the video here, take a second, and see if you can solve this. All right, let's walk through this step by step and see if we can figure out what's going on. Now, we know that in a system that does not have any external forces, momentum is conserved. But we cannot jump to that here because it does not tell us there are no external forces, and it doesn't tell us it's frictionless. So we're going to have to do this mathematically. So I know that object X is 2 kilograms, and I know object Y is 2 kilograms. Object X starts out with a velocity of 4 meters per second. If I multiply that by 2, I end up with a positive 8 meters per second. Object Y has got a velocity of negative 2 meters per second. So they're heading towards each other. This has got a mass of 2 kilograms, and we're going to multiply by minus 2 to give us minus 4. So our net momentum initial is going to be equal to 4 kilogram meters per second. So what's our final going to be? Over here, we see the two objects stick together. So we are thinking that this is going to be an inelastic collision. We have both of the objects are traveling at 1 meters per second, and the mass now is 4. So my final momentum is going to be 4 kilogram meters per second. So yeah, momentum is conserved. Check. That eliminates C, and that eliminates D. But now in order to understand if it's elastic or inelastic, for sure, to prove it, they stick together. So if you were doing this on a test, you could pretty much skip this last step and go straight to B. Kinetic energy is not conserved because the objects are sticking together. That's always an inelastic collision. I can't think of any time that has to be inelastic. Yes. But let's just prove it by calculation. So we start off, and my initial kinetic energy here, 1/2 times the mass times the velocity. So my kinetic energy at this spot is going to be 16. My kinetic energy down here, 1/2 2 times 2 squared is going to be 4. So my KE initial is 20 joules. My KE final is 1/2 times 4 times 1 squared. So my KE final is going to be 2. So most certainly kinetic energy is not conserved, and my answer here is B. All right, last practice problem. It's another multiple choice. Let's roll this right on down. Okay, so here we go. I've got block X of mass M travels in the positive direction with a speed Vx towards block Y of mass M that is at rest, as shown in figure 1. After the collision, block Y travels with a speed of Vy in the positive direction, while block X remains at rest. The horizontal surface that the blocks slide across is considered to be smooth, so we're ignoring friction, basically. How can a student determine whether the collision is elastic or inelastic? Go ahead, pause the video, see if you can answer. Okay, welcome back. So let's walk through this. It says that the surface is considered to be smooth, so we can assume there is no friction. So we can also assume that there are no colors here. There are no external forces. So we know that momentum is going to be conserved. So the student only needs to observe A, that the blocks do not stick together after the collision, which means the collision is elastic. We said in the last video, you cannot do that. You cannot assume just because they bounce off of each other that it is elastic. You have to do a calculation to prove it. So A is out. The masses of both blocks are known and the initial and final velocities of both blocks are known. Therefore, the student must compare the initial momentum of the two-block system before and after the collision. Nope, we know it's going to be conserved. That is not going to help us understand if it's elastic or inelastic. C, the masses of both blocks are known and the initial and final velocities of both blocks are known. The student should use P equals mv for block X or Y to determine the block's momentum has changed. Nope. The only thing that's going to do it for us is D. We have to calculate the before and after collision kinetic energy. That's the only way to tell, certainly, whether something is elastic or inelastic. Okay, you've got some practice problems to do in the homework, so we will see you in the next video. We're going to talk about what happens when we're not just moving in one dimension. We're going to go to two-dimension collisions.